Hello dear AI enthusiasts, welcome to a new video where we'll be looking at an exciting development in the AI landscape, the Hunyuan T1 model from Tencent. This new AI model is causing quite a stir in the tech world, as it's not only the first large AI model based on the Mamba architecture, but it also outperforms established models like DeepSeek R1 and even OpenAI's GPT 4.5 in some benchmarks. Let's take an objective look at this model, examine its capabilities, and determine its position in the global AI race. Before we dive deeper, if you want to stay informed about the latest developments in the AI world, subscribe to my channel now and activate the bell. You won't regret it. Hunyuan T1, sometimes simply called T1 or Hunyuan Thinker 1, is a new AI language model developed by the Chinese tech giant Tencent. It's an AI reasoning model that builds on their previously developed turbo architecture and is optimized for logical thinking and complex tasks. What distinguishes Hunyuan T1 from other large language models is its architecture. It's the first ultra-large-scale model based on a hybrid Mamba-Transformer-MoE architecture. This innovative combination promises significant advantages over conventional transformer-based models. Unlike traditional transformers with their quadratic complexity, Mamba works with linear complexity. The computational effort only increases proportionally to the sequence length. The Mamba architecture is based on state space models, SSM, which process information more efficiently through their state preservation as they move token by token through the sequence. One of the outstanding aspects of Mamba is its selective state space mechanism. This allows the model to decide which parts of the input to focus on and which to ignore, similar to how attention works in transformers, but without the high computational cost. This increase in efficiency leads to several concrete advantages. Hunyuan T1 can generate 60 to 80 tokens per second. It can efficiently process very long text and context. Computational resources are significantly reduced, and the decoding speed is, according to Tencent, 200% faster than traditional architectures. I was able to test Hunyuan T1 myself, and I must say, I'm impressed. In one experiment, I had the model compete against GPT 4.5 to see how quickly it could create a 200 token essay, while GPT 4.5 took about 2.8 seconds. Hunyuan T1 did it in approximately 3.2 seconds, only minimally slower despite its more complex reasoning capabilities. I also tested various other tasks, from creating an SVG logo for a fictional IT company to calculating optimal angles in physics problems. What impressed me particularly was the transparency of the thinking process. Hunyuan T1 shows how it arrives at its results, which is incredibly valuable for complex reasoning tasks. If you want to experiment with the latest AI models yourself, let me know in the comments. I can give you tips on how to access these technologies. Now to the crucial question, how does Hunyuan T1 compare to other leading models? The benchmarks are impressive. In the MMLU Pro evaluation, T1 achieves 87.2 points, R1 84, O1 89.3. In reasoning categories, T1 outperforms with 93.1 points both DeepSeek R1 92.2 and OpenAI O1 90.2 and GPT 4.5, 84.7. Particularly notable, in the code evaluation, T1 achieves 64.9 points. GPT 4.5 only reaches 46.4. Also in mathematical tasks, AIM 2024, and the Chinese C-eval test, T1 is on par with the top models. These figures show that Hunyuan T1 not only can keep up, but is even leading in some areas. In independent tests, Hunyuan T1 shines in logical tasks, mathematical problems, Python programming, and generating HTML, CSS, JavaScript, and SVG graphics. It also excels at complex physical and scientific questions. Its strengths clearly lie in the mathematical, logical, and programming technical area, while it still shows potential for improvement in creative tasks such as specific haiku patterns or interactive audio applications. Do you find these benchmark comparisons as exciting as I do? Hit the like button now if you want to see more such detailed analyses of the latest AI models. Another decisive factor for the success of an AI model is the pricing strategy. Here, Tencent positions itself with T1 extremely competitively. T1 costs about 1 yuan, approximately 14 US cents, per 1 million tokens for input and 4 yuan per 1 million tokens for output. For comparison, DeepSeek R1 charges 1 yuan per million tokens for input during the day and 0.25 yuan at night, while output costs 16 yuan during the day and 4 yuan at night. This aggressive pricing strategy could be a decisive factor in gaining market share, especially for companies that process large amounts of data or generate extensive text outputs. Tencent is massively increasing its AI investments, $11.7 billion in 2024-2023, $3.4 billion, of which $5.4 billion in the fourth quarter alone. Tencent's dual-core strategy is remarkable. The Wenba chatbot integrates both T1 and DeepSeek's R1. This flexibility aims to keep WeChat with its over 1 billion users at the forefront of AI experiences. Developers can choose between these AI models for different tasks or combine them. Hunyuan T1 is part of an intensive AI race in China involving big names like Tencent, Alibaba, Baidu, and ByteDance. All are working to consolidate their leading position in the areas of generative AI, large language models, and advanced reasoning systems. Alibaba recently announced that it will invest at least $52.6 billion in cloud computing and AI over the next 3 years. ByteDance, the company behind TikTok, has allocated over $20.7 billion for 2025, much of which is also earmarked for AI infrastructure. This competition is partly driven by the success of DeepSeek, which has proven that technology developed in China can compete with Western counterparts like OpenAI. The development of Hunyuan T1 and similar models has far-reaching implications for the global AI landscape. China shows with models like T1 that it is capable of not only keeping pace with leading Western AI labs, but even outperforming them in certain areas. The successful implementation of the Mamba architecture on a large scale could initiate a trend away from pure transformer models and lead to more efficient AI systems. The aggressive pricing of Chinese models could exert downward pressure on global AI prices, which would promote the accessibility and spread of these technologies. The focus on efficiency could help reduce the enormous energy consumption currently associated with training and operating large AI models. Hunyuan T1 marks a significant advance in AI development. Its innovative architecture, performance, and competitive pricing make it a serious competitor for established models. Tencent plans to openly share the weights of the model in the coming months. Exciting questions remain. Will OpenAI respond with an even stronger model? Will others adopt the Mamba architecture? How will this increase in efficiency affect the AI landscape? One thing is certain, the global AI race will be further accelerated by innovations like Hunyuan T1, and we can eagerly observe what groundbreaking developments will follow next. What do you think? Could the Mamba architecture be the future of AI? And how will the increased competition from China affect the global AI landscape? Share your opinions in the comments so that we can discuss the latest developments in the AI world together. Write your questions and thoughts about Hunyuan T1 in the comments below. Have you had experiences with similar models yourself? If you like this update, leave a like and subscribe to the channel. And if you activate the bell, you'll even be informed when we upload a new video. I hope to see you next time. Until then, stay real.